what I want to try to do today is to give an introduction to what CIDOC CRM is briefly, and then how it would be used in a project and in an institution to make better data. So the actual practice of, okay, we want to use semantics and we want to use this ontology, but how does that actually get done? And so obviously that's a big topic to cover in an hour. And also, not everybody who's with us necessarily ever wants to do this sort of work. So I'm trying to present it at the level of this is basically what goes on in this work, so that you can have an understanding of what's involved and the kinds of questions that come up and the kinds of things that you have to do. Hi, Catherine. So that's the topic. And I will spend some time talking to you, and then maybe I'll ask for some participation. So going back to the beginning, what is CIDOC CRM? And there's a lot of ways to talk about this, but I would say you can think about it as a way of organizing your data to be compatible with others, a way of making your data more interesting to search, and a way of making your data more sustainable and reusable. So I have these silly illustrations, but data is something that we produce in research, especially in archaeology, and it's the manifestation of our intellectual work. And yet the topic of managing the data itself can often be overlooked, and it's not a primary topic of thinking through and creating a long-term plan, which is unfortunate because we use it to actually carry out our research endeavors and to ground our argumentation in articles and so on and so forth. So oftentimes people data looks like this terrible spice drawer that you might find, and you can't find anything, and things have been mixed with other things, and you can't easily move forward and take up the spice drawer and make some nice new food. Whereas if you had thought through your spice management, then you would have a nicely ordered set of spices, or appropriate containers in the appropriate order, and you would quickly be able to make some sort of recipe. So by analogy, CIDOC CRM should help adequate to represent that, and which other people who understand how to use the ontology can look at and immediately say, ah, that's that, and perform a query, link their data to that data, because it's established a ground level of compatibility and common understanding. By the way, if at any point you want to stop me, just turn on your microphone and stop me. Very happy to have questions live, etc. So if you like that idea, then the next obvious question is, all right, how do I do this semantic data modeling? So that's and there are two terms that go along with CIDOC CRM. It's an ontology or it's semantic, and I'll get into what those mean in more detail in a second. But basically, if you're doing research and you're creating analytic data, then you already do data modeling probably, or somebody's doing it for you. You set up an excavation, you set up a literary research project or what have you, and you're collecting certain kinds of information. Then you're going to adopt a tool, an Access database, a FileMaker database, an Excel spreadsheet, a Google spreadsheet, a commercial software tuned more or less to your needs. But probably in the normal case, again, the focus of your research is your research and not data management. And so there isn't necessarily a deep thinking about data structures or a long-term plan of how to organize and make your data understandable and connectable with other data sets, and even to yourself, to future researchers, or even to future you trying to come back to your data at some point in in the future. So the promise of CIDOC CRM is to be an intellectual and practical tool that allows you to accurately represent the information you're collecting about the world, and do it in a way that is self-describing and allows you to join a community of other people who use that same standard. And it's different from other standards where you'd say, okay, we want to have compatible dig data, so we'll all use this software, which is great, except for if the software doesn't match your style, and then you have to use a different software, and then your data isn't compatible with other people, or maybe you can't afford it, or whatever. CIDOC CRM doesn't offer you a set standard. It offers you a way of structuring data, which you can do in multiple environments, etc. So I wanted to go back to this point about what is ontology and what is semantics. And so I'll do a very brief resume of the history of ontology and semantics. But basically, you could argue that CIDOC CRM and other ontologies like it all harken back to this sort of the work of Wittgenstein in the Tractatus, where he's making this fundamental thinking about how language functions and how representation functions and what it does. And he talks about the fact that there are all these different modes of representation, whether it be a painting or a musical score or the written word, and there's something about them. There's something common in their logical form that allows them to represent the world and that point us to a reality and say something about it. And that's what he calls the proposition. And so then we don't really want to do Wittgenstein's work for him, but what he gave us as an idea was you could come up with logical structures for, you could isolate the kinds of propositions you would make about the world, and then make a little formal language about them, which would allow you to describe the things that can be said about the world. And so computer scientists sort of broached this topic and thought, well, when we build databases, and when we build spreadsheets, and when we build programs for people, basically we're giving them a tool to make propositions about the world. And so if you have a medical register, you're making, when you fill in the entry, you're making a statement about the world. There is a patient, the patient does have this problem. But every time we build this, we build it in a different way, and we don't think fundamentally what is the scope of the things that the people who use this system want to say, and how do they connect? So what is the logical picture of their world that would be sufficient to describe the kinds of things they say? And if we could describe that, then we could build a database or a system that would be compatible, because we wouldn't constantly make them slightly differently, because we would all use the same propositional types. In my silly example here, if the domain of interest was this, if my world was dogs sitting in chairs and tables, then I would isolate that there is a kind of thing that is table, a kind of thing that is chair, a kind of thing that is dog, and the possible modes of relation between them are tables can be in front of chairs and chairs in front of tables, and dogs can sit in chairs or chairs can be sat in. So that would be, if that was the job done, that would be great. It's obviously more complicated. So that's the sort of brief theoretical background. And then if you want to do this work of saying, we're going to create a mini language that has just the propositional types, the kinds of things that people want to say for a domain of research or a domain of thought, then we're also going to have a way to actually express this in an information system, a kind of syntax for our language. So the most popular one in ontology and semantics is called the Resource Description Framework, or RDF. And it basically gives you two tools for expressing yourself. One is a class, and a class is like a generic noun. You basically say, we have this kind of thing, and then you define in a definition, in a scope note, it's also called, what this kind of thing entails. So, tables. Tables have 4 legs and they have a flat surface, and you can use them for the following kinds of activities. Would be a bad definition, but one that you could make. And then you have properties, and properties link 2 classes, and they allow you to express relationships that hold between things in the world in these simple sentences that are structured in a sort of subject, verb, object kind of way. And they can be extended infinitely. So subject, verb, object, etc. And so you make these pithy little statements, which individually don't tell you much, but if you put them all together, they make a graph of information, which creates this picture, this propositional picture of the world as I presented before, now in an information system. So you can ask questions of it like, how many tables are there in the world, etc. So just to give a real world example, you might want to discuss Athens, and you could say Platia Varnava. It would probably be underneath a class like places, and then you might have a property to describe places like their style, and then you might have another class which is a typology of styles, and one of those styles would be hipster hangout. So that's the kind of sentence, simple sentence you could make in using RDF and an ontology to give you the classes and properties that define your domain of interest, your world of reference. So far so good. Can't see you, so I'll take it as yes. So then some more background information. So I already mentioned that RDF expresses itself in classes and properties. It has a few other basic mechanisms that are interesting to know to understand how this form of data representation works. So these things in rectangles now are classes defined in an ontology, in a toy ontology I made up for the purpose of this presentation. And so I've defined 3 classes: animal, bird, and dog. And you'll see that there's this relationship represented by this arrow between bird and dog, between bird, dog, and animal. And that relationship is called ISA. And ISA is the technical word in RDF for inheritance. And what it basically means that every instant, or every a class defines a set of real world things. So animal, all those things that have motion. Use your Aristotelian definition of what an animal is. There's a real set of things in the world which are the animals. And then I can define a subset of the animals, which are animals, but specifically they have their specific difference. They have wings or whatever it is. So we also have birds. But the ISA relationship says that all birds are also animals. And likewise, all dogs are also animals. Obviously, you all know this, but we can represent that in the information system. And then that becomes interesting, because we have the information system here, which uses the ontology, which is our small, defined, formalized language, which allows us, the classes allow us to point to things and say, animal, bird, dog. And then we have our world of reference. So with this little ontology, we have a real world, and I can use bird to point out this budgie or this emu. I can use dog to point out this puppy. And I haven't created a special class for walruses, but I still have some expressivity because I do have animal, so I can just batch my walrus underneath animal, which is a useful feature when knowledge is expanding and you don't know where you want to put things. And so that means that we have the ontology level, we have the world that allows us to talk about, and then we have a sort of epistemological layer which is, okay, what does this information system then allow us to ask and do? And so the inheritance function is useful because on the one hand, I can ask questions like, show me puppies, which would be return me all instances of dog, and I'd only get this guy. Or I can say, show me birds, and I would get 2 instances of things, my budgie and my emu friend. Or I can say, how many animals are there? And I search on this animal thing. And even though I haven't said this budgie here is a bird or is an animal, and I haven't said that this puppy here is an animal, nevertheless, the system knows all birds are animals, all dogs are animals. So it will give me, to my question to the information system, how many animals are there? It will say there are 4. These are those 4. So that's for classes in inheritance. Then we need to talk about properties in inheritance. And it's basically the same thing, but it's interesting to point out because it's a powerful feature. So properties allow you to specify kinds of sentences you can make between classes. So in my toy ontology here, I'm interested in whether or not the animals have limbs, because maybe they've been losing limbs. I don't know. So I've defined at the animal level that there is a property has limb, and it points to a class limb. So that means I can talk about, hands and leg, or arms. Sorry, Greekism. Arms and legs and wings and whatever, and they'll all fall underneath wings or under limbs. But I might have more specific knowledge, and I want to express that specific knowledge. So I actually know that birds happen to have not just limbs, but wings. I'm interested in that particularly. So I can specify new, more special properties that are more accurately expressing my knowledge. And so I would say about birds that they have wings and dogs that they have legs. And then we still have the same principle of inheritance between properties and properties as we did between classes and classes. So I can ask, show me all the animals that have legs, and because I've defined having legs as only belonging to dog, it will only return me dog. But I can also search on show me all the animals that have limbs, and then because my birds will have wings and my dog will have legs and my walrus will have limbs, I can get back all the animals nonetheless. And this is really useful for making a flexible, expressive language for expressing knowledge in an information system, because sometimes you have accurate levels, highly precise levels of knowledge, and sometimes you have vague levels of knowledge when you're entering data. And there's also the question of when you're looking for data. So when you once you've created data in a semantic structure like this, and you approach it not from the point of view of knowing what's in the database, but wanting to explore and understand what knowledge it contains, you can use these high-level properties to ask really general questions, and you get returned a lot of information. And then because the information is structured using these quasi-real world sentences like has wing, has leg, you start to see the meaning of the ontology itself, and you can say, oh, okay, well, I'm actually not just interested in people who have or animals that have limbs. I'm interested in the animals that have wings, and so I will refine my search and I will get closer to the information I want. Obviously, I hope you can make the analogy from my toy example to more serious academic endeavors. And the last thing I wanted to say as background to semantics is this question of domain and range of properties. So domain and range of property is part of the definition. I said at the start, like if you make, when you have a class in an ontology, you declare it and then you just write a textual description for human beings to read to understand how to use it. So you say what an animal is for you. And then when somebody enters data in a system using that ontology, they should know animal means this. So put animals here, put fungi there. We have the same thing for these properties. So they get a scope note and it says having limbs means, having, I don't know, I can't define what having limbs is off the cuff, but you probably have an intuitive impression. So there'll be a definition of what having limbs is, but then for the computer system, we want to create a formalism that will make it so people make sensible sentences and queries are sensible. So we want it to be the case that animals, that you can make the sentence or ask the sentence, which animals have limbs, and then get back the animals in your system that happen to have limbs, because some of them have lost limbs. Maybe you're a veterinarian, I don't know. But you don't want to be able to say which fungi have limbs or which furniture have limbs, because it's nonsensical for furniture to have limbs. So you want to exclude the possibility of people saying things that don't exist in the world. And you can do that by doing what's called restricting the domain and the range. And so when you define a property like limb or like wing, you say it's only the case that has wing is something that you can state about a bird, and you can only connect it to wings. So you can't say bird has wing, leg. You can only say bird has wing, wing. And that's an important feature for, going back to Wittgenstein. He said, you shouldn't make sentences that point to non-realities. And this is a way of stopping the information system from allowing nonsensical sentences to be made. So hopefully that wasn't too much background. So all of that is the intellectual substructure that's used to do semantic modeling. And then if you want to take data that you already have and express it in using an ontology, that's an exercise you can do, and it would, the end goal is that you put your data into this ontology and either expose it so that other people can make use of it in various ways, either just in general or within an institution or within a research project. Or you might actually want to make an information system where from the start, all of your data is going to be semantic, so that you know that it's well categorized and well described and can be easily shared with other people adopting the same semantics, the same ontology as you. So that would be what a semantic project is using CIDOC CRM in practice. And so now I'm going to describe how that's done by somebody, either a researcher who takes up interest in this, or somebody who specializes in doing semantic modeling. So to do this, you basically start with your data, and this is key because it goes back to the Wittgensteinian thing. You need to know the world you're describing and the kinds of sentences you're making. So you need to go back to your research and say, what are my data fields saying about the world, and what am I trying to say through them? And sometimes you're analyzing somebody else's data because it's an old project that you want to integrate the data in. So they might have described their data structure, so they have a data schema. So there you want to do a sort of critical analysis and say, okay, they say that this table describes these things and this field describes that aspect of these entities. But you have to critically analyze it and say, what's the data in here, and did they actually use the database correctly, or did they say something else using this data structure? So on the one hand, you need to think about your data source that you want to make compatible with others, and on the other hand, you need to know your target. And the target is the ontology that you're going to use to semantically re-represent your data using this technique of RDF and adopting a particular vocabulary, a particular ontology like CIDOC CRM. So just to say, you know, as a matter of what actually should go on or does go on in these sorts of exercises, practically speaking, you should start with a knowledge of the things that you want to integrate as data. So that's a list of your data sources. I want to describe database 1, 2, and 3 using CIDOC CRM because they all talk about the same excavation. And if the data was integrated, then I would be able to do a better analysis of the stratigraphy or the events that happened on that site. So you list out your databases, and then for each database, and that a database can be an access or a spreadsheet or whatever, you need to have a description of the schema of that. So it's either a fancy manual for the database, or it could just be something written out by the person who built the spreadsheet saying, this field describes who did the work. This field describes this date, and so on. And you want to look at sample data because sometimes what you imagined you would use the spreadsheet for ends up being different from what you actually do. And then you need to read the ontology, which is an ontology is not something magical now, hopefully. An ontology is actually just a list of classes and properties. So classes giving you the noun structures to point at things in the world and say, that's a table, that's a dog, that's a chair. And properties which allow you to make connections between the things that you point out in the world. So chairs go under tables, dogs go under chairs, so on and so forth. So you need a description of that ontology, then it'll have a formal encoding normally, which is usually some sort of version of RDF, the thing I talked about above. And then you, having read both those things, you try to make the connections between them by taking your source and making mini sentences using the ontology to describe what's in each field and eventually re-encode your data semantically. And just to say that all of that should initially happen with a pen and paper, and then eventually, if you're transforming existing data, because it's not just an intellectual exercise, I'm just going to let somebody into the room. If you're not just doing it for kicks and you actually want to get something done, then you would actually have to take your data modeling and put it into a software that would allow you to take your initial spreadsheet data, your initial access database, and pass it through a system with a set of instructions to say, this field means this in this ontology, this field means that in this ontology, so that you can get your new integrated database using the semantics. And so, yeah, and then thinking about the methodology of applying CIDOC CRM to existing data, it is, you move one step away from your research, so you're not thinking about the content of, I'm describing this particular site or what have you, and you're having the meta conversation with yourself of, I use this spreadsheet or database to talk about these kinds of things, and this particular field makes this kind of statement about it, the propositions, the Wittgensteinian propositions. So as a matter of practice, it's interesting to look at a data source and say, what is this data source about? What is the primary thing that is described in this data source? And then for each of the fields that are in that data source, so that could be columns in your spreadsheet or fields in a table, you'd say, what kind of statement does this field let me say about the thing that I talk about with this tool, with this descriptive tool, which is my database or my spreadsheet? And you can write those out as natural language sentences, maybe because it's helpful. The ontology tries to replicate a sort of formalized way that we talk about things scientifically, and so that makes the transition between the table-like structure to the subject-verb-object operation more obvious. So that, by way of what you should do and think about in analyzing the sources, or whoever was undertaking that work. And then, of course, the question comes, okay, what about this CIDOC CRM that I would be using to translate my data? How could I appropriate? Oh, I just did a Trump. I can't actually hold a cup with one hand. CIDOC CRM is this ontology. It has 90 plus or minus classes, 160 plus or minus properties, and so it has a reputation of being complicated to understand. And so then there has to be some sort of approach to that. And the first thing I like to say is that it is trying to be a mini formalized language. It's the scope of this ontology. It started from museum data and it's grown to cultural heritage data. The scope of the ontology is supposed to be describing real-world events in the past and the interactions of objects, ideas, and people at different times in different places. So it's a really human-level description of the world. It's not a biology or physics ontology. It has very real-world classes and properties that you use. And if you think about it as a language and think, if you learned 90 classes and 160 properties, which are kind of equivalent to 90 nouns and 160 verbs, and you could describe all cultural heritage data and link it together. So you could have your excavation database and your museum database and your accurate analytical botanical reports, and they could all be joined together through the accurate deployment of your 90 nouns and 160 verbs, then obviously that sounds like a reasonable and interesting investment as opposed to learning, I don't know, Italian or Mandarin. So finally, well, not finally, but getting into how this, getting into something sort of hands-on-y. The last thing I want to point to is this general CIDOC CRM schema. So I just said that there are sort of 90 classes and 160 relations, but the whole thing follows this event-oriented modeling. And event-oriented modeling basically means that within the context of doing cultural heritage and historical research, what we're interested in investigating and making propositions about is the sort of trajectory of things through time. And so we move away from an object-oriented approach, not in the technical sense, but if you think about like a museum database, what do? You open up your database and you describe an object. In this ontology, the central thing that's described are the events that, not described, but used to connect things, are the events in which objects participate. So we don't say this object 1982 because that's semantically unhelpful. Does it mean that it was created in 1982 or destroyed in 1982 or dug up in 1982 or modified by a conservator in 1982? So instead, we talk about the event of creation of an object, the event of discovering an object, the event of the cleaning of the object, and so on and so forth. So even though there are 90 classes and 150 relations, they're basically, we have this hierarchy like I described in the beginning, where we have these high-level classes and everything else underneath them is just a specialization of the high-level classes. So just like my animal ontology had bird and dog, CIDOC CRM has these five sort of high-level things. We have the temporal entity, and then specialization of temporal entity, like an activity carried out by a person, or I don't know, a transfer of ownership. We have conceptual objects, which are things thought up by individuals. So their ontological nature is an idea, and it can only be created by people. And once it's thought up, it exists in people's mind and on physical objects, because you write it down or paint it or whatever. And it can exist in multiple places and continues to exist until we forget about it and all copies are destroyed. Physical objects are the things that you know from the everyday world: tables and chairs and cats and dogs. Places are geometric locations or geometric specifications on a real world object at which events can take place. And actors are people like you and me, and institutions like the UN and the American government, which are capable of making in a Kantian sense, an intentional act in the world and do things on purpose. And just the other thing to note, I already sort of said it. So if you're documenting things in time in CIDOC CRM, then you're always thinking about what event is this the time of? So we never say, object, or I don't know, the idea of Maxwell's equations, 1911, because that's actually a shortcut for Maxwell thought up his equations in 1911. I don't know when he thought up his equations, I'm just saying. And two other things to say about the ontology. It has these high-level classes, also appellation and type. And appellation and type are basically, appellation is name, and so anything in the cultural heritage world and anything in the human world is often named. It's my cup, it's everything can get multiple names, and we classify things continuously, so everything in the CIDOC CRM world can be typed in multiple ways. So I call it a hammer, you call it a doorstop. Now hopefully we get slightly interactive, or at least I really struggle with using an hour to do a workshop on CIDOC CRM, because it's nice if you can get your hands on it, but the time is limited and the virtual environment isn't great. So basically, I guess I'll sort of perform some mappings for you, but I've also, with the help of Denitsa, created some sample data that you could work with this if you're interested, of course. It'll just be free for you to look at. And then, within our Google chat or within just email exchanges, we could talk more about that for those people that it becomes a topic of interest. So thinking about CIDOC CRM as this ontology, that's a language that allows us to describe a real world. This is looking at the very top of the ontology. The top of this real ontology is CRM entity, which is any real world thing. And it has three basic properties defined for it. So is identified by, which points to an appellation class, that's a name. The color coding means yellow things are concepts, gray things are a classification. You'll see it as we go further down. And anything you can attribute a type to. So what that means is if there was a real world mug and it was my mug, then CIDOC CRM would allow me to represent that as mug. This mug is an instance of CRM entity. The name George's mug is an instance of E41 appellation, and the relationship between them is that the name George's mug identifies this thing. And also the classificatory term come up by the great archaeologist so-and-so mug applies to this particular kind of object and not to some other. That's a lot of background and only 10 minutes for some practice, but what can you do? So if you're getting into the practice that I was saying earlier, or somebody you're working with because you're going to do a semantic project, and you've got somebody doing that, the questions that you can basically ask to try to learn CIDOC CRM and start mapping your data to it at the same time is to go from a top-down approach and ask of your data, what does this describe? And you've already done this pre-study where you've written down my schema talks about this. And then CIDOC CRM provides you these high-level classes which have specializations, but you just first cut up the world into a basic question of, does this document that I'm going to translate, does it talk about events, as in temporal activities that take place over time? Does it talk about places in the sense of a geographic area somewhere? Does it talk about actors in the sense of people and groups that can do Kantian causal actions in the world? Is it talking about physical things in terms of tables, chairs, cats, and dogs? Is it talking about concepts in terms of ideas? Or is it talking about a time span or a dimension? Don't worry about those last two so much. So you can basically do this sort of animal, mineral, or vegetable sort of questioning, but in CIDOC CRM, these are the top level categories you would think about. And you start from there, and then once you've decided which direction you're going, then you can dig into the ontology. And so I'll just point to it here. I've shared this presentation so you can use it if you want. Even the ontology has all these very specific classes. It has these high-level classes that describe everything, or the basic pattern for everything that happens below, and give you the most general level relationships. So thinking about, if we ask the question of our data, is it event, place, actor, physical thing, or concept? We said, okay, actually, my form talks about an event of excavation. Then you could go to the ontology, and now you know about classes and class hierarchy. So the highest level thing is the most general, but the least specific. So you'd say, okay, well, I'm talking about a temporal entity because it has time, and I'm interested in describing that. But I also want to talk about the fact that it took place somewhere. And so with temporal entity, because of this domain range story, I can't talk, the only thing I can talk about is time span. But with period, I have a new property I can use, took place at, and that allows me to talk about places. Well, the thing I describe in my data structure is both a temporal thing and it takes place somewhere. So I need something better than temporal entity, I need period. And then you say, oh, but I'm also talking about, in the thing I'm mapping, I'm talking about the people who do this work. Well, if I look at the ontology, I can see period it allows me to say this event had a time span, this event consists of other events, this event took place somewhere, but it doesn't allow me to talk, it doesn't allow me to make any connections to actors, and I need to talk about actors. So then you go further down and you'd say, okay, actually I'm talking about events, because the three things that I describe in my spreadsheet are time when it happened, where it happened, and who did it. And so I will choose event, and I will begin to map my information that way. So hopefully that's not too abstract. And can you still see my screen? Great, okay. So in our last minutes, we get to an actual example. So this is a sheet that Denitsa prepared, thank you, which mimics, a possible real-world spreadsheet for documenting things in an archaeological context. So Denitsa, would you describe in a sentence or two what this spreadsheet does?
Right, so in this spreadsheet I just put basic information that would refer to most of excavations. Why do I hear myself in the feedback? Anyway, I'll try to...
I'll turn my mic off.
Oh, great, thanks. If you can put back that spreadsheet, great. So we usually start with some sort of excavation unit, whether we're going to call it layer, level, or excavation unit, or just unit. It's usually the unit that we excavate within. And that unit has following information. So it has the date it was opened, the date it was closed, the excavation technique that it was excavated by, the used tools, some sort of general interpretation of the unit, other units that it relates to, trench supervisor, of course the trench that the unit was opened within, or any other larger unit of measurement at place that we decided to use. Different files associated with it, which is like the photograph or any sort of drawings or sketches. And of course, anything else that you would decide to add to illustrate basic features of an excavation unit as it goes. And George will continue with the rest.
The basic idea then would be that this is the perfect kind of object for translating into the ontology, and then you wouldn't have to learn this spreadsheet 10 years later because you would have saved it in a format that was reusable over time. And how we would do that is, the first question we would ask about the entire spreadsheet is, what does this thing talk about? And we would, in terms of category of thing, so going back to our list here, does it talk about an event? Does it talk about a place? What is the main topic of it? Does it talk about an actor, a physical thing, or a concept? So that you have 2 seconds of interaction. Does anybody want to venture a guess as to what it describes? There are wrong answers, but there will be no judgment. Well, I'll give the first answer, which is the whole thing, because it has dates, is probably talking about an event. So the event of excavation. So the way that you would sketch this sort of mapping out in diagram form, for example, would be to make a little box that says, okay, this spreadsheet, each instance of it talks about an event. I'll give a simple one. And then you go field by field and you ask, what does this particular field talk about, or column in this case? So what kind of thing does trench supervisor talk about if between the high-level categories you have to choose between event, place, actor, physical thing, or concept? I trust somebody can answer this question.
Actor.
Cheers. So then you would say, okay, look, oops, sorry, didn't want that one. Let's go with actor for now. So then we have actor, and then we're getting to, so now we've basically come to the point where we said, this table points at the world and says there's an event, and it also points at the world and says there's an actor. But that's kind of a autistic thing to do if you're not going to make the connections to get really a rich information. So the spreadsheet doesn't just say there was an event and there was an actor. It says there was an event and this actor did something in it. So then when I want to start, that's where I start using properties to make these little sentences. So then, because I've chosen an event, I can go into looking at the ontology. Where was that? Oh yeah, over here. And I can look at the top level and I can try to find an appropriate property. And I actually have one here. It says this event had participant. Maybe there could be a better one, but that's already making a connection. So then you would draw this out. P11 had participant. This is the intellectual exercise you would do for all of the fields. First you do it on paper, but then you could use a system to transform this, and what you would get would be, with this sort of modeling and mapping, the transformation software would make a set of statements which would say there's 1, 2, 3, 4 events that took place, and event 1 had participant George, event 2 had participant Elon Musk, event 3 had participant Peter Pan, and event 4 had participant Queen Elizabeth II. I, as predicted, didn't have as much time as I would have loved to, but just to give you a picture of what you could arrive at, you can arrive at a relatively complicated model out of that spreadsheet that talks about the fact that you have an event that took place somewhere, that had a time span, that is called something, was carried out by somebody, that destroyed a layer, that created a stratigraphic unit. The stratigraphic unit was represented by a picture. The stratigraphic unit was measured and had a dimension. The stratigraphic unit had formal physical relationships of being under or over, etc. And so the idea is, and I know I'm over time, so I'll stop in a second, but the notion is you could, be, I don't know, one theoretical scenario, you're picking up from an excavation that happened in 1960 and it had relatively good data, and you want to carry on and merge that information and get some new insights by carrying on with your excavation. You could re-represent it in this format, because you wouldn't want to use the 1960s one, I imagine, and merge in your additional data and start creating a continuous, formally represented, available to everybody and self-documenting information structure for this work. So with that, unfortunately, I'm going to have to come to a close because we're out of time.